Hey everyone, we're going to continue our discussion with complex roots and talk about completing the square in order to get complex roots. So if you recall, there's a few different steps when dealing with completing the square. It's a When you get the handle of it, it can actually be a lot quicker and easier than using the quadratic formula, but there is a lot more to remember. So this picture kind of gives a breakdown of what you have to do. You first have to write the equation so that it equals to zero. You move this last term, the c term, over to the other side. Then what you do is you add half of whatever the middle term is squared to both sides. So in this case, half of 4 is 2. 2 squared is 4, so you add 4 to both sides. Factor this so that you get something like x minus 2 squared, and square root both sides to get rid of this square. Then you just follow up and solve. This kind of breaks it down again. These are all the steps. Rewrite the equation. It didn't say that it before, but you have to make sure that a is actually equal to 0. So if you have something in front of the a, you have to basically divide everything by a. Move the c term to the other side. Add half of b, and then square, adding to both sides. Factor the left side, square root both sides, and then solve for x. So we're going to do some practice questions dealing with this. Once again, it's going to be about four, two questions from the guided notes, and then two from the independent practice. All right, so here are the first two questions from the guided practice. Again, you have to use a completing the square process, so pause the video, work yourself. We'll go over it in a second. All right, so the first thing that we need to do for question one is we need to move the 20x and the minus 64 over to the other side. So we end up having 2x squared minus 20x plus 64. Before we even continue doing completing the square, there's a non-1 term in front of the x squared, so we have to divide everything by 2. So 2 divided by 2 is 1, 20 divided by 2 is 10, and 64 divided by 2 is 32. So we get this. Then what we have to do is we're going to move the 32 over to the other side. So we have x squared minus 10x equals negative 32. We take half of 10, so that's 5, and square it, add that to both sides. So we have a 5 squared here and a 5 squared there. This is going to factor as x minus 5 squared. Now, again, remember the shortcut. Whatever sign that goes between them is whatever sign is in front of the x term. So because this is negative, this is also going to be negative. And then the term that's with the x is going to be whatever half of that middle term was that you ended up squaring. So that's actually why I kind of leave it as 5 squared rather than 25. So this will end up factoring as x minus 5 squared. And then over here, we just actually put that in the calculator. Negative 32 plus 5 squared, which is 25, will give us negative 7. Take the square root of both sides. And remember, when we do the square root, it's going to be plus or minus. So we get x minus 5 equals plus or minus rad negative 7. 7 is not perfect square. In fact, it can't be factored anymore. So all we can do is just move an I in front of it, move the 5 over to the other side, and we have 5 minus I rad 7 and 5 plus I rad 7. So those are going to be our two roots. For the next question, number 2, do the same thing. We're going to move the 10x and the plus 4 over to the other side. So we get x squared plus 6x plus 11 equals 0. I don't have to do anything with dividing or simplifying anymore. So we just move the move the 11 over to the other side to get negative 11 there. Take half of the middle term, which is 3, square it and add to both sides. Because the sign in front of the 6x is positive, I'm going to put a positive here, and then the 3 drops down here, so this factors to x plus 3 squared. When I plug in negative 11 plus 3 squared into the calculator, I get minus 2. Take the square root of both sides, so I get x plus 3 and then plus or minus rad negative 2. Just like up here, I can't really factor 2 anymore, so all I can do is move the negative over outside of the radical and put an I there. So I end up getting my two solutions to be negative 3 minus I rad 2 and negative 3 plus I rad 2. Here are the next two questions. Pause video, work in self. We'll go over in a second. All right, so from the independent practice, this first one, it's actually already set up so that it equals to 0, so I can actually jump straight to moving the 25 over to the other side. I take half of the middle term, which is 2, square it and add to both sides. So this, the negative 4, tells me that it's going to be negative in the factor. 2 squared, so I drop the 2 over here. So I have 2x minus 2 squared. And then negative 29 plus 2 squared is negative 25. Take the square root of both sides. 25 is a perfect square. It's going to be, so radical minus 25 is going to be 5i. When I move the 2 over, I get my two solutions, 2 minus 5i and 2 plus 5i. All right, and then the very last question, move the 7x and the 10 over to get this as my new quadratic. Move the 40 over, add half of 12, which is 6, 6 squared to both sides. When I factor this, minus goes in my factor, the 6 also drops down. So I get x minus 6 squared equals negative 4. Take the square root of both sides. Square root of negative 4, that factors to be 2i. So when I move the 6 over to the other side, I get my two solutions to be 6 minus 2i and 6 plus 2i. And that's pretty much it. So this actually is a lot simpler than quadratic formula in the sense that, unlike with the quadratic formula, you don't actually have to do any division or anything. You kind of go straight to the final answer. Like I said, it's a lot of steps to remember, but as long as you're doing it constantly and making sure that you're doing these practice problems, it starts to become a little second nature. If you have any other questions, please let me know. Otherwise, I'll see you later. Good luck and have a great day.